All right, we are on section 14.6. We're taking a look at triple integrals today, so basically just the same idea as double, but bumping it up a notch. So one thing that we're going to start with as an introduction is an application to triple integrals. So to help us get an idea of what this application is going to look like, I want us to think back to how we used either a single integral or a double integral to look for areas between curves. So when I had some picture like this, when I had the area, right, like below f of x but above g of x from between a and b, we did this back in Calc 2 where we looked at this as being a single integral, where we did the integral over the bounds of like top curve minus bottom curve, or if I wanted to, I could have drawn this as right curve minus left curve. But essentially, right, larger minus smaller, and then have the appropriate change in variable. So instead, though, what we just learned a little bit ago was that I instead could write it as a double integral. So I could do the integral from a to b of the integral from g to f, and just integrate 1 and do that dy dx, that this integral finds that area. So basically what we have is, rather than on the inside of the integral doing that f minus g, or incorporating that f and g in the bounds of an integral, and then they end up, once you evaluate that integral, coming inside and being a subtraction. What we're going to do in this section to kind of introduce this idea of triple integrals, one application of them is we can do a similar idea with volumes. So if you think about what we did in our previous sections when we learned double integrals, is we did do volumes between surfaces, where we did it by doing like top surface minus bottom surface. So this would be something where, you know, I've got some sort of top, so Z is bounded by like a top surface and a bottom surface, and then that's all over some region R in the plane. So we maybe have bounds for X that are between A and B, and then for those X's, we've got that Y is bounded between two curves of X. These could be switched backwards, right? You could instead have like X is bounded between two Y function curves, and then Y has numeric bounds. Basically, you've got some region in the xy plane, and then we've got two surfaces, a top surface and a bottom surface. Where the bottom surface might be the xy plane, it might be z equals 0, but it might be something else as well. So if this does enclose a solid, then what we can do, this is what we did before, right? So we did the double integral, which basically finds that area of the bottom, and then we did the top surface minus bottom surface. So it kind of is this, you sort of get a feel, right, of area of the base times the height to get that volume. What we're going to be able to do instead is, rather than have these curves on the inside of the integral, we can put them into an integral bound. So we can do a triple integral. So we've got the integral from a to b of the integral from h of x, h1 of x to h2 of x. So these are the x's, these are the y's, and then we do the z's. So then we've got g1 of xy and g2 of xy, so bottom surface, top surface. And then the same way we did with area, if we're looking for the volume, we just integrate 1. And then notice now we've got 3 little integration variables where we would do dz, dy, dx. Now in theory, like the dy and the x, you could flip-flop back and forth if you decided to represent your region as like a right curve, left curve instead of top curve, bottom curve. But we would have 3 functions. So kind of one thing to pay attention to, right, is notice now this time my innermost integral bounds can be a multivariable function, where it can be a function of both of the other sort of quote-unquote constant variables with respect to z, and then the next one we'll just have a single variable functions. So like if we're doing dy, then it can be functions of x, and then the last one is strictly constant bound. So you kind of have that progression as we go through. So this is just an application of a triple integral. So in this section, we're going to practice both. We're going to just practice in general triple integrals. So we might just have a simple triple integral setup, and we may or may not integrate one. And then we'll also practice some examples where we do find volumes using triple integrals. So we'll take a look at those here in a minute.